In this video, I'm going to talk about ion, ionic compound, and nomenclature of them. First, what is ion? Ion is an atom or a group of atoms that has charge, like sodium, positive 1, potassium, positive 1, calcium, positive 2. So, or it can have the negative charge, like fluorine, negative 1, oxygen, negative 2, and nitrogen, negative 3. Ion with positive charge, we call it cation, and ion with negative charge, we call it anion. Positive and negative charge, they can have a strong attraction force and form a stable crystal lattice that we call it ionic compound. One of the most famous ionic compound we use it every day is table salt, sodium chloride, that has sodium positive and chlorine negative. We always need to keep in mind that the charge for positive and negative ions should neutralize each other. So for example, if we have sodium and oxygen for making an ionic compound, we cannot just have NaO because this is negative 2 and this is positive 1. So the subtotal of charge for this compound is negative 1. So the ionic compound for sodium and oxygen doesn't have this formula. Because we have 2 negative charge here, we should have 2 of positive charge here. So instead of 1 sodium, we need to have 2 of sodium cation. So we should have 2 sodium, and in the formula number of sodium, we show it on the right and bottom, and this is oxygen. So this is the ionic compound for oxygen and sodium. To make it easier, we can have a general rule. This is the general rule. If we have a cation with N positive charge and we have an anion with N minus charge, when we want to write the formula for these two, always we need to write the cation first at the left and anion at the right, and then we need to switch their charge or cross it down. So we need to bring the charge for the anions here, and we need to bring charge for cations here. So the formula for this compound will be in this form. The next step is how we should know what is the charge for the cation or anion. If we look at the periodic table, we can find most of these answers. On periodic table, group 1A has hydrogen, lithium, sodium, potassium, rubidium, and cesium. It is group 1A, so it can make cation with positive 1. So group 1A always make positive 1. Hydrogen is not metal, so it doesn't form the ionic compound. For group 2A, we have these elements here. We don't consider the beryllium for the ionic compound because it's not completely metal. But the rest of these elements, they have positive 2 charge for the cations. So group 1A has positive 1, group 2A has positive 2. So when we check the periodic table, we can understand what is the charge for our metal. For group 3A, some of them have non-metallic property, some of them they have metallic property. But mostly in this level, we have only aluminum that has positive 3. For non-metal group 7A, it's halogens. We have fluorine, chlorine, bromine, and iodine. They will have negative 1. Group 6, we have oxygen, sulfur, selenium, and so on. The charge for this group will be negative 2. And for group 5, we normally only consider nitrogen that has negative 3 charge. So this is the general rule for having the charge for the monoatomic ions. If we have polyatomic ions, there is a table we need to memorize their charge and their name. I'm going to explain it at the end of this video. So let's have some example for writing the formula. I would like to write the formula for magnesium and nitrogen. If we have an ionic compound for magnesium and nitrogen, what is the formula for that compound? And keep in mind always we should have the simplest ratio in the ionic compound. So we need to check the table and see magnesium has positive 2 and nitrogen has negative 3. Then we have magnesium 2 positive, nitrogen negative 3. So the formula will be Mg3N2. because we need to switch this charge for the writing the formula. Let's write the formula for potassium and oxygen. So potassium is +1, oxygen is -2. So the formula will be K2O. And of course we have 1 here, but in the formula we don't write 1. Sodium and nitrogen, +1 and -3. The answer will be Na3N. Calcium and oxygen. Calcium is +2 and oxygen is 2 negative. So the formula is calcium 2O2. But we need to have the simplest ratio. We can simplify these two. And the formula is CaO. So if we are able to simplify the ratio of the cation and anion in the formula, we need to do it. Formula for ionic compound is the simplest ratio of the cation and anion on the lattice structure. For nomenclature of the ionic compound, we need to mention the name of cations and then name of anion. The name of cations normally refer to the name of the element. So here we have magnesium. So the name of cation also will be magnesium. But for anions, we need to have this IDE at the end of the name of anions. So we have nitrogen. The name of the element for N is nitrogen, but it will convert to the nitride. For the second example, we have potassium. Instead of oxygen, we write oxide. So name of anion at the end should have IDE. Again here, sodium nitride. And here is calcium oxide. Let's have more example for nomenclature. Here is 3 more example. So the name for these elements for the cation is aluminum and the name for the anion is oxide. Second one, cation is calcium and the name for the anion fluorine convert to the fluoride. And last one is sodium and instead of sulfur we have sulfide. You can find table for the name of all of cations and anion in the textbooks and internet. There is a series of metals. They have more than one type of cations. Most of them they belong to the B groups in the periodic table, transition metals. So let's have some example for them to see how we can write their name. For example, iron has 2 types of cations, iron 2 and iron 3. So if I want to write the formula for these cations and chloride, we have this formula for their ionic compound. If I want to name it like the previous examples, both of them will be iron chloride. So we need to make a difference between these two names. So to make a difference, we should mention this iron in this compound has what type of cation. It has 2 positive charge here, it has 3 positive charge here. So we can show this positive charge for each cation by a Roman number in the parentheses. Then when we read this name, it is iron 2 chloride, iron 3 chloride. And please keep in mind this number is for their name, not for their formula. When you write the formula, don't write iron 3 chloride, something like that. Here is more example. For each of these metal, I wrote 2 different compounds to show you how we can write their name. So on the previous, for the iron, we start from the cations. We knew what is the charge for that. But for this example, we need to find what is the charge for copper and for cobalt. This is copper and the name for anion is chloride. And again here we have copper and the name for anion is iodide. But we need to find what is the charge for coppers. We need to look at these numbers for anions because this number came from the cation charge. So on the first example, we can see it was a +2 here, then these 2 move to the chlorine. So this copper is +2. So the correct name for this compound is copper 2 chloride, not just copper chloride. And on the second example for copper, iodide has 1 here, so it was +1, then this one came here. So it is copper 1 iodide. We can have same performance for nomenclature of these 2 cobalt compounds. It is cobalt. The charge for this cobalt is 2. And for the second one, the charge for cobalt is 3. On the last part of this video, I'm going to explain about polyatomic anions and cations. For polyatomic ions, we don't have too many cations. So we have 2 famous cations. NH4 positive, and the name for this cation is ammonium, and another one is mercury 1. When we have mercury 1 in the formula, we cannot simplify these numbers if we have something like this, because the whole of this part, it is cations. So this number is not coming from the charge, so we cannot simplify it with that number. So it is an exception. But for anions, a story is different. We have too many polyatomic anions that we need to memorize their name. I'm going to list a few of them here. Here is a series of the name for some of the famous polyatomic anions. There is more, and you can find it on the textbooks and internet. The name for the first one here is carbonate. So for carbon, we have only one type of polyoxy anion. But if we have two types of anions for one element, if we have more oxygen, we use ATE suffix. If we have less oxygen, we use ITE. So the name for the first one is sulfate, and for the next one is sulfite. Same for these two nitrogen anions. Nitrate, nitrite, and so on. For group 7, like chlorine and bromine, we have 4 different types of anions. So the one it has highest oxygen number, we use a prefix per. So perchlorate. Then the next one is just chlorate. Then chlorite. And for the last one, we use a hypo prefix. Hypochlorite. If we have hydrogen before one of these anions, like this example. When we have hydrogen, we should reduce the charge. So instead of having CO3 with 2 negative charge, we have 1 negative. So there is 2 different methods for naming this type of anions. We can say hydrogen carbonate, or instead of hydrogen, we can say bicarbonate. Same for the other type of anion. So if we have HSO4 negative 1, we call it bisulfate, bisulfite, and so on. For nomenclature of the ionic compound for this type of anion, we have same thing. But sometimes for writing the formula, we need to use parentheses too. Let's have some example. Let's say I would like to write the ionic compound formula for aluminum and sulfate. So I need to cross the charge here. When we have more than one polyatomic anion, we need to put it in parentheses. So aluminum has 2, but we cannot write SO4 It doesn't make sense because we may see SO43. So instead of writing in this form, we should put the whole polyatomic anion inside of the parenthesis. And the naming is same things, aluminum sulfate. Here is more example, calcium, and the name for anion is nitrate. For second one, magnesium sulfite. Thank you for watching this video. Please subscribe our YouTube channel.